All right, today we're doing notes number 32, which is graphing cosecant and secant functions. And because both of those are reciprocal functions of sine and cosine, we want to start with their respective reciprocal graphs. So if I'm trying to graph cosecant, first I'm going to figure out what's going on with the sine graph with the same a and b value. Once I get the sine graph sketched in, which is this, remember, so once I get this sketched in, anywhere the sine of x equals 0, so anywhere you have a point on the midline, that would be a vertical asymptote for cosecant. Because we know from our unit circle trig, anytime we have sine equal to 0 and we take the reciprocal of that, that becomes 1 over 0 or negative 1 over 0. And so that's undefined. This would be anywhere sine x is equal to the midline. If you've done a vertical shift. So even if you've shifted up 10 units, now it's anywhere sine is sitting on 10 instead of on 0. And then we want to plot the common points between sine and cosecant. So think about the sine graph. The reciprocal of 1 is 1, and the reciprocal of negative 1 is negative 1. And then I want to sketch in the branches of the cosecant curve. So think about this. Wherever the sine graph hits 1/2, the cosecant graph will hit 2, the reciprocal of that. Same thing over here. And every time you have a fraction here for sine, anything between 0 and 1, when you take the reciprocal of that, you'll get some sort of number that's larger than 1. So this branch is going to open up. It's not a parabola, but it's just like a curved branch. And the same thing will happen in the negative direction. So the reciprocal of negative 1/2 is negative 2. And so this branch would open down. All right, so let's take a look at this one. Graph y equals 3 cosecant of 2x. So start by graphing y equals 3 sine of 2x. Once you get the sine graph, that's where all of the work is, and then you're just filling in asymptotes and drawing branches. So let's take a look at this one. The amplitude of the sine graph is 3. We don't say that a cosecant or secant graph has amplitude because there's not like a max or min connecting back to the midline. But the amplitude of the sine graph is 3. The period is 2 pi divided by b, which is 2. So that's pi. And I will look at the asymptote equations after I get this graphed. So if we have a period of pi and I'm trying to sketch this sine graph, I like to mark off the end of the period. So we're going to go from 0 to pi. And remember, when we're doing a sine graph, this parent function, these points, they occur when you're splitting the period into 4 equal parts, right? The nice non-quadrant angles. So divvy this into 4 parts. So cut it in half, cut that distance in half. That would be pi over 4. And then that shows you that you should have a point plotted every little half box. So put another point right here. That would be 3 pi over 4. So the first period I'm going to graph of the sine graph would start at 0. At the next pi over 4 box here, it goes up to 3. 0, negative 3, 0. So here's one period of the sine curve. Now remember, to get the cosecant graph, you are going to sketch in vertical asymptotes anywhere the sine graph hits 0. So there's one at 0, there's one at pi over 2, there's one at pi. And then you can sketch in the branches of the cosecant graph. So they both have this point at 3 and negative 3. And remember, the branches will turn away from the sine graph. I didn't mean to go through the asymptote there. Let me fix that. There we go. And I'm not requiring you to plot any extra points on here, but just try to fit the branch into the width of the asymptotes. Now, I still want you to fill the window. So from here, you could either just use a pattern of like, okay, so they're going to be asymptotes every pi over 2. Or if you want, you can keep going with the sine curve. But I'm just going to do asymptotes. When the period is pi over 4 on this window I'm giving you, this can get pretty tedious and pretty cluttered. So I'm just going to do the asymptotes. Let's copy them over onto the left side. This is the smallest period I would give you to sketch by hand, just because anything smaller than this, if I keep everything to scale, can get pretty messy. Okay, So vertical asymptotes. And remember, the next sine graph would come up here and then back to 0 and then back down here. So see how these branches are going to alternate? So you can just kind of every other now say, all right, that one's going to be there. Now this one's going to be down here. Again, I'm not too picky on the accuracy of the branch itself, but you do need to plot the 1 point that's at 3 or -3, and then carry on from there. And on the left side, so we were at pi over 4, we were at +3. So at negative pi over 4, we should be at -3. And I'm just going to keep going with this pattern. Just be careful that you're not skipping a box or something. These are periodic functions, and it's easy to accidentally skip something and mess up the pattern. So you don't want to be rushing too fast through this. All right, last branch. Okay, when you graph secant and cosecant, there should be this big empty space in between the branches because that's where the sine or cosine graph would exist, and we're doing the reciprocal of that. So what about the asymptote equation? The asymptote equation is saying, all right, x equals, we want to give some statement that would generate any asymptote anywhere. So take a look at these. They're at 0, pi over 2, pi, 3 pi over 2. They're all one box apart, and one box on my scale is pi over 2. So you can say 0 plus pi over 2, and really it's any multiple of pi over 2. So multiply that by k and make a statement that k needs to be an integer. K is an element of the integer number set. You don't have to write the 0. You also, I don't care if you simplify it or not. The reason I'm pointing that out is there's not always a vertical asymptote that goes through 0. So if there's not, I would pick one that I see and then add to that this distance. How did I know this was pi over 2k? Well, they're all pi over 2 apart, but also the distance between the asymptotes for a cosecant graph, same thing for the secant graph, it'll be half of the period. So if the period's pi, they should be pi over 2 apart. Because remember, on the unit circle, there are two places within one period where sine hits 0, and same with cosine. There are two places within one full circle period where cosine hits 0. So it's going to be halfway. Once you're halfway done with the period, you hit 0, and then halfway again, you'll hit 0. All right, here's another cosecant graph. So this one is y equals negative, let's think of it as negative sine of x over 2. Remember, the amplitude of the graph is the absolute value of the coefficient out in front. It's a distance between the midline and the max or min, so 1. The period is 2 pi divided by 1/2, which is 2 pi times 2, so that's 4 pi. And I'm going to wait on the asymptote equation. So the period is 4 pi. So again, I like to mark that off. So we're going from 0 to 4 pi. Cut that in half, 2 pi. Cut that in half, pi. So there should be a mark every pi units. So I have one at 1, 2, 3, and 4 pi. This is a negative sine curve. So remember, the negative sine curve starts at 0, but then it goes down to its amplitude of -1, and then back up to 0, back up to 1, and to 0. So again, we can sketch in our vertical asymptotes. Excuse me. It's nice when they're wider than this. It doesn't take as long to graph everything. We can plot the common points. So the reciprocal of -1 is -1. Same with +1. The branches open away from the sine graph because all of the reciprocals will be fractions outside of the -1 to 1 range. All right. Now I want to continue this on though. So what's next? So these are 2 pi apart. Or again, you can keep going with the sine graph if that helps. Looks like this. And then the branches have to be in the exact center between the asymptotes if you haven't graphed your sine curve. So here's one. And because I'm not requiring you to plot any extra points, just fit the branches to the width of between the asymptotes. It would be wrong to say it's going to look like that, So keep them at just about the width there. And then what's the asymptote equation here? So this would be x is equal to, so just find one to start. It can be any one of these. I'm just going to say 0 again. I usually go for 0 or the first positive one I see, and then not comma. And then I want to add to that the distance between asymptotes, which I can see pretty easily when it's at 0. The next one's at 2 pi. Or remember, it's half the period, so 2 pi k. K has to be an integer for that to be true. And again, you don't have to write the 0 for that. What about graphing cosecant? What about graphing secant? So the same rules that we use to graph cosecant, we will use to graph the secant function, but it's a reciprocal of cosine. So when I'm trying to graph this equation, I'm going to think of it as y equals 2 cosine of 2x. The amplitude of the cosine graph is 2. The period is 2 pi divided by 2, back to that annoying narrow graph. And we'll get the asymptote equation when we're done. All right, so if the period is pi, let's mark off from 0 to pi. Cut this into 4 equal parts so you can get your nice points here. And again, you need to memorize the parent function, what I'm calling the parent function of cosine, meaning the cosine graph starts at its amplitude. So 2 is where it starts on the y-axis, and then it hits 0, and then down to -2, 0, 2. So here's our first cosine curve. Again, you don't have to sketch it in, but there it is. We would then have vertical asymptotes through the places where cosine equals 0. So they're going through halfway from 0 to pi over 2. So they're going through pi over 4 and 3 pi over 4. And so I can write the asymptote equation right now. There's one going through pi over 4 rather than 0. And if I add to that the distance to the next one, well, how do I know the distance to the next one? I can subtract 3 pi over 4 minus pi over 4. Or remember, it's half the period. So if the period's pi, it's pi over 2. As long as k is an integer, that's true. And then the branches on this do the same thing. So here we're going to have a branch. I really only have a half branch right now. This will get fixed in a second. And here we're going to go down. But again, I do want you to fill the window. So you can either continue on with the cosine graph, or you can say, all right, so the asymptotes are basically between every box I have labeled here on the axis. So I could just do it like this. I'm not requiring you to label where the vertical asymptotes are. That would get too cluttered. And the reason we're filling these windows is just to really emphasize the fact that all of these trig functions, we will do all 6 eventually, they're all periodic and they go on forever. And even though it's kind of tedious sometimes to fill a window like this, it's a bit easier because you just have a pattern that you're filling out. So let's do the other half of these branches just so it stops looking so weird. Okay. And then these are going to alternate just like the other ones. So in between the next 2, I should be down at -2. And then up at 2. And then -2. And you just keep alternating. Again, these are not beautifully sketched graphs. Just try to make sure that you're not getting too sloppy. I can get a little half graph here. You don't want to get too sloppy and like go through an asymptote. Let's go to the negative side and do these. And we're almost done. Like I said, when I quiz you on this, I'm not going to give you a lot that have a period of pi. Probably one graph like this will have a period of pi. That's about as tedious as it gets. Oops, I can do one more little half. There we go. One more little half guy there. All right, and then what about this one? So this says graphs y equals secant of pi x over 2. So there's a pi in the b value. The amplitude of the cosine graph is still just 1. The period would be 2 pi divided by pi over 2. And remember, every time we divide by a fraction, it means multiply by the reciprocal of the fraction. So the pi's will cancel out and you'll get 4. And that means the period is 4 radians. And we did talk about where 4 radians falls. It's somewhere in quadrant 3. It's past pi radians, but short of 3 pi over 2, which is 4.71 approximately. And so I'm not going to have you put 4 radians somewhere on the scale, although we could. It's like maybe here or something. But instead, just for simplicity's sake, let's just renumber the axis. So let's just say 1 pi is 1 radian, 2 pi is 2 radians. So just to make things a bit simpler, I would have a scale that's numbered differently for you if it were something like this. So anyway, it just, if I want you to fill the window, it's okay to do like 1 period and approximate where 4 radians is, but it can get kind of tricky to keep going from that. So, okay, so let's say 4 radians is really where the 4 pi used to be. So cut that into 4 equal parts, which just means you're going to plot a point every 1 unit or 2 boxes. And this is, again, is a cosine graph. So it's going to start at the amplitude, go to 0, -1, 0, 1. Put in asymptotes anywhere the graph is going through the x-axis or the midline. You can continue on your cosine graph if that's easier to see. There should be another vertical asymptote at -1, one at -3. And the branches still open and go the opposite direction, opening up to about the width of the branch fairly quickly there. And both of these secant graphs kind of ended with little half branches. That typically happens with the window I give you and the kind of graphs that we're looking at. So the asymptotes for this one would be x is equal to, there's not one at 0, so just pick one that you see on here. I'm just going to go with the first one at +1. What's the distance between them? It's still half the period. Half the period is just 2 times k, and k is an integer. Or, check your graph. The distance between 1 and 3 is 2. Distance between -1 and 1 is 2. So most of the work for getting the proper setup for these is still just correctly graphing a sine or a cosine curve. And then the part that can be a little bit tedious is going through and sketching all of the asymptotes and branches. But otherwise, there really aren't that many extra steps as far as what we do for these graphs.